Section 5.5 is on absolute value inequalities. In this section, we're going to extend the idea of inequalities to involve those that have absolute value in them. Absolute value inequalities turn into compound inequalities. They turn into either an and or an or. So let's take a look at the first one, an absolute value less than inequality. So these are going to have a less than or a less than or equal to symbol in them. These are going to turn into ands. So if it's a less than, it turns into an and. Here's how I remember it. It becomes a less than. So let's take a look at how we're going to do this. So solve and graph the absolute value of x plus 2 is less than 11. Since this is a less than, it's going to turn into an and inequality. And the way I like to do it is write the inequality without the absolute value bars. Okay, since it's got a less than sign, let's put another one in front of the x plus 2. And since I have a positive 11 here, I'm going to put a negative 11 there. So let me go through that again. Write the inequality without the bars, put another less than symbol in front of the x, and put a negative of whatever the number is on the right. Now we just solve this. Notice it looks like an and inequality that we saw in the last section. So my goal is to get 2 in the middle all by itself. So to get x all in the middle all by itself. So I'm going to subtract 2 from each part. So 13 is less than x, which is less than 9. And then to graph that, I'll have a negative 13 and a 9. Open circle on those two numbers and draw the line in between. So my less than turned into an and. Let's take a look at another example here. I have the absolute value of x minus 8 is less than or equal to 2. It's a less than, so it's going to turn into an and. Copy the problem without the bars. So x minus 8 is less than or equal to 2. Put another less than or equal to sign in front of that and put a negative 2 in front of that. Now let's solve. I'm going to add 8 to each part so that I can get an x in the middle all by itself. That's going to give me 6 is less than or equal to x, which is less than or equal to 10. And actually, let's take a look at that, see if that makes sense. So 6 is less than x, which is less than 10. If I were to ignore this x in the middle, 6 ultimately is less than 10. So that makes sense. To graph that, I'll have a 6 and a 10. Closed dots over each of those and a line in between. And let's take a look at one more with a less than. This is the absolute value of 2x minus 5 is less than negative 3. Now whenever you see a negative number not inside the absolute value bars, you have to stop and think about it. Okay? What's going to be going on here? No matter what I put in for x, I'm going to take the absolute value of it and it's going to turn into a positive number. Remember, absolute value talks about distance, but it also actually practically turns negative numbers positive. So no matter what I put in for x, when I multiply it by 2 and subtract 5, even if it's negative, it's going to end up being positive. So are there any positive numbers that are less than negative 3? There are not. So there is no solution to this one. There is no number that I can put in for x that's going to make that true, because the bars are going to make it a positive number and it cannot be less than negative 3. Now, the second type of absolute value inequality we're going to have is a greater than. These are going to turn into or inequalities. And the way I remember that is it's a greater. So I'm going to take my absolute value and write it as a compound or inequality. Let's take a look at a couple examples here. Solve and graph the absolute value of 3x plus 6 is greater than or equal to 12. So this is going to turn into an or. So first thing I'm going to do is write it without the bars. Okay. And remember in the last section when we were doing compound inequalities, we can write an and without the word and, but you have to write an or with the word or. So definitely put the word or in there. And now take the stuff between the bars, and instead of a greater than or equal to, make it a less than or equal to, and instead of a positive 12, make it a negative 12. So what was between the bars is going to be greater than a positive number or less than a negative number. And now let's just solve each part. Subtracting 6 and dividing by 3. So x is greater than or equal to 2, or, don't forget that in your answer, subtracting 6, 3x is less than or equal to negative 18, dividing by 3, or x is less than or equal to negative 6. Let's graph that. I'll have a 2 and a negative 6, so I need greater than or equal to 2. That's that piece right there, or less than or equal to negative 6. And that's what our classic OR inequality looks like. Let's do another one of those. The absolute value of 2x plus 1 is greater than 7. This is a greater than or equal to a greater inequality. So it's going to turn into an OR. So my first step is to copy it without the bars. Write the word OR. Take the stuff between the bars. Instead of a greater, we're going to make it a less than. Instead of a positive 7, I'm going to make it a negative 7. And now just solve each piece. Subtracting 1 gives me 2x is greater than 6, and dividing by 2, x is greater than 3, or subtracting 1, 2x is less than negative 8, and dividing by 2, x is less than negative 4. And we'll graph that. Negative 4, 3, greater than 3, open circle since it's not an or equal to, or less than negative 4. And there's my graph for that. And our last example is another curveball here. So we have the absolute value of x minus 6 is greater than negative 5. So whenever you see a negative out here with absolute value, you've got to stop and think about what's going on. Okay, so remember in the previous one I said the bars are going to turn this side of the inequality into a positive number. Okay, so no matter what I put in for x, I subtract 6 from it, even if I put in a negative number for x and subtract 6 from it and get another negative number, the bars are going to turn it positive. So is a positive number greater than negative 5? Well, yes, every positive number is greater than negative 5, so the answer to this is all real numbers. I can put in anything for x and it will always be true. So in this section we took a look at absolute value inequalities and how they turn into compound inequalities. How a less than or a less than or equal to turns into an and inequality. How a greater or a greater than or equal to turns into an or inequality. And don't forget the two kind of curveballs whenever you have a negative involved on the right side of the inequality.